Give you objects to throw at her.
Okay. Jorge Luis Borges, pardon my Spanish, is a famous Argentine writer, and he said this about infinity. And the first person to appreciate this problem was probably Zeno. You're familiar with Zeno's paradox, probably, that you can't get out of this room, because to get out of the room you got to go halfway. Well, let's do it with the tortoise. The fast-running Achilles can never catch a slow-crawling tortoise that's got a head start, because Achilles has got to run to where the tortoise is, but when he gets there, the tortoise isn't there. The tortoise has crawled a little bit ahead, so he's got to then run to where the tortoise is now, but by the time he gets there, again, it's crawled a little farther ahead and so forth. So it looks like there's an infinite number of places Achilles got to go to catch the tortoise, and surely he doesn't have enough time to go to an infinite number of places. So therefore, fast runners never catch slow runners. Okay, Zeno's treatment of that was to say that, well, this just shows that the concepts, the Greek concepts of space, time, and infinity are incoherent, that transcend human understanding or something like that. That was a mistake, but that's okay. I'm ready to go ahead. So if there aren't any comments on Zeno, we can just cruise ahead here. Go ahead. There are three ways to be infinite. You can be infinitely large, you can be infinitely small or infinitesimal, or you can be infinitely numerous or infinitely many. So infinity comes in different styles or different kinds. And I'm going to make a radical claim about all this, about the nature of infinity. Not one that I feel quite so strongly that I'd fight that hard about, but I'm going to try it out on you, and you can tell me what you think. That you are changing slides without me holding up my hand here. But don't do that. Just wait till I hold my hand. Okay. So, what my claim is that there are. That's plugged in right now, right?
Yes.
Okay, so I can't just carry it over here. So my claim is that there exist physical infinities of all those three kinds. Many people don't believe that, but I'm going to try to present my reasons, sort of explain in detail then what the thesis is, and then consider all the various counterattacks that can be made, starting with the weak ones and going to the stronger and stronger ones. So, meanwhile, you're going to be thinking about how you can refute my position possibly, or think of better reasons for why it's correct. We'll see. My claim is going to be based on the fact that you ought to accept scientific theories and their implications. And I also claim that scientific theories allow for physical infinities, and in addition, it actually requires them. But I'm not going to give you an argument from authority which says Einstein believes this, because he doesn't. If he was in the room, he'd be going, wait a minute, I don't agree with you. However, I'm going to claim that his theory of relativity does, even though he didn't appreciate that. So to get clear about what my actual claim is, I'd like to talk about what infinity is. There are many conceptions of infinity, but three basic categories, three kinds of infinity, three different concepts. One is transcendental infinity, the other is oftentimes called transcendental infinity. Another is potential infinity, and the third is actual infinity. And you can go back one. Sorry. And they are identified with the people in the bottom. So a lot of my slides are just alike, except if you switch over, you get a new word. So that's why it's tricking you up.
Right.
Yeah. Okay, so this is very similar to the previous slide, but now we've got people associated with those views. Aquinas would say, for example, God has a transcendental infinity. This is a kind of infinity that's supposed to be beyond human understanding. the term infinity used to have, back in ancient Greek times, very negative connotations. And over the years, several hundred years, people started associating it with God's properties. And then the negative connotations went away because anything associated with God had positive connotations. Potential infinity is, the modern version of potential infinity arose from Aristotle's old version of potential infinity, which is thinking of infinity as a process, not a thing or a state or anything like that, but it's a process, an unending process. If it's unbounded, then it's infinite. So he thought that you could say that the runner Achilles, who's chasing that tortoise, goes through a potential infinity of places, but not in what we now call an actual infinity. That is, you don't complete it at one time. There isn't at one time an infinite number of spaces. That's contributed in the mind of the analyst, Aristotle would say. Okay, now the notion of actual infinity, which is probably what you talked about yesterday at Philosophy Club, is also called completed infinity. It has a few other names. Actual infinity is the one that's perhaps most popular. And that comes from a definition of infinity by Dowden in 1888. And he said that for purposes of mathematics, we want a concept of infinity, at least for sets. And a set is infinite if it can be put into one-to-one correspondence with one of its proper subsets. If you can match up, like the integers, he would say, are infinite because you can match them up one for one with the even integers without having anything left over. Any set that has that property is called infinite, and any set that doesn't have that property is called finite. And this has turned out to be fantastically fruitful. It's now the set theory that was developed by a guy named Cantor using that definition has been very fruitful. It's used now as the foundation of calculus, which is something we'll never live without because it's so useful in the doing of science. Okay, so my thesis then is that I can give you examples of actually physically infinite entities in the world. So we're only going to go with the third one, number 3. So here's a suggestion for what is infinitely large in the sense of actually infinite. That the center of a black hole is just a point, has 0 volume, but it's got mass and curvature and temperature and all that kind of stuff. So this is an implication of Einstein's theory of relativity, that there can be black holes. It was a surprise to Einstein when that was discovered about that Russian astrophysicist Friedman, I think was his name. Oh, and the Big Bang is classically conceived as sometimes the term is used, singularity. A point place having infinite values. So the inside of black holes have these singularities, and the origin of the Big Bang claim here is that it has those, has that feature. In itself is a singularity. My second example of a physically infinite thing is a moment, an instant, a point duration. Not quite like a minute. And I can give you other examples of infinitely small things. Places. Those points that Achilles has to go to catch the tortoise. Okay, let's try another. Okay. And for infinitely many. Here's one that will probably be a bit more surprising. If you consider a free electron, that means one that's not bound inside an atom, it's not captured by a proton. It's just out there zipping through space all by itself. Okay? If it accelerates, it's going through a change in energy. As it accelerates, it gets more and more energetic, right? Or if it decelerates, it gets less and less energetic. Right? But E equals mc squared. We know that from the special theory of relativity. So its mass, not its rest mass, but its mass in motion will change just as its energy changes. In a sense, there's really no difference between mass and energy at some level. There's really just a thing called mass energy that's fundamental in the world. Okay, so the claim here is that there are infinitely many different masses present in the universe when an electron speeds up. That is not a picture of an electron, it's just a picture of a bullet, right? But it makes you think about motion. And the bullet is free from the gun. So it's not being accelerated by the gun anymore. But it is being accelerated by the air, it's being decelerated, if there is any air. I don't mind, by the way, I don't mind people speaking up in the middle of my talking here. It's like you don't have to sit around and wait until an hour from now to say anything. The second kind of, you got a signal for me there? Or sometimes, but that's fine, but it's just try to sync with my hand. I know you're anxious to see ahead. What's going on? A second example of infinitely many is the places that Achilles has to go in order to catch up to the tortoise. There are an infinite number of places between your nose and my nose. Right? Between here and the North Star. And if the calculus is to be believed and the mathematics behind it, Cantor set theory is to be believed, and the nature of the continuum is the structure of real physical space, then there are many places between your nose and my nose as there is between your nose and the North Star.
Is that like segments of space? Like
No, it means small points of zero length. The measure is zero. If you have any finite length, then there's only a finite number of those you can lay down until you get to that goal.
yeah.
So
All right.
that's called the Archimedes axiom in number 3. That given a finite length, if you have enough of them, you can extend them and reach anywhere. Okay, so now that's my thesis. Now let's take a look at what my opponents will say. Okay, there is my first opponent in a blue jacket. And I probably could use a straw man argument to defeat this guy. Let me tell you what he thinks. What does he know? He thinks 1 + 1 is 3. Okay, but there are other opponents. Let's take a look at René Descartes here. Well, you remember him from way back? That's his comment on the infinite. I'm upset with that last sentence. I think you can coherently think about the infinite even though we have a finite number of neurons in our brain and a finite number of neuron states that they could have, even though it's huge and the brain is the most complicated physical object in the universe for its size. But who's he to say nobody has any business to think about such matters? Unless you're gone. He's like making, I think, some theological remark like, only God is the infinite and mere mortals can't understand God, therefore quit trying. Something like that. I'm just guessing what he would say here. I wish we could just call him up and ask him. But unfortunately, can't do that. But here's my refutation of Descartes. It goes like this. Yes, I have a finite mind, right? But I understand philosophy 60 and the operation of negation. And I know what's finite, but the infinite is just the negation of the finite. So hey, I understand the infinite. Or at least I can understand the infinite. Anybody want to shoot down that remark before I go to the next one? So you're confident you can think about the infinite? Okay. Doesn't mean you know everything about the infinite. It just means you can know it because you can understand not finite. There's a lot to understand about infinity, but we're a step at a time, so to speak. Okay. Now, I have other opponents like George Berkeley and David Hume. And they were bothered by the atomicity of sensation that they discovered, and that they're radical empiricists. All knowledge comes from sense experience, that kind of thing. And sense experience is atomistic at some level. And who could detect an infinity with your sense organs? You can't. So Dowden should just shut up and quit. That's probably what Berkeley and Hume would say. To which I say, look, you can't detect electrons or space with